All right, welcome to part 2. We're going to be going now writing these from vertex form into standard form. So I'm just going to write those base equations up here. We're going to go from this form to this form. Whoop. This form, which is the vertex form, into our standard form. So what do we have to do? Well, it's very simple. All we have to do is expand this out by doing some simple multiplication and foiling. So all we're going to do is, remember, when we do this, everybody wants to do this. Everybody wants to first distributive property this. You cannot do that first because according to BADMAS, we have to deal with the exponents first. I know there's brackets here, but we can't deal with the x because we don't know what x is. So we're going to deal with exponents first. So I'm just going to rewrite this out. What does this mean? Well, it's got to be the thing in the brackets multiplied by itself twice. So x minus 2 squared is x minus 2 times x minus 2 plus 1. So now all we have to do is, we could do it two different ways. I could multiply this in. I'm just going to start foiling this. I'm going to leave the 3 on the outside. And then I'll worry about the 3 at the end. So first, x times x, x squared. Hopefully at this point we are pretty confident in how to do this. And if not, we're coming to office hours so we can go over how to do this because this is a very important skill. So I did first, x times x is x squared, x times negative 2, negative 2x. Then the inner ones, negative 2 times x is negative 2, negative 2 times negative 2, positive 4, because two negatives make a positive, plus 1. So now I could just multiply this in. I'm just going to clean this up a little bit. 3x squared minus 2x minus 2x is minus 4x plus 4 plus 1. Now I'm going to just keep expanding. I'm going to multiply this into all of this. Remember, expanding means make bigger. So we have to multiply to make it bigger. So we're going to get 3x squared minus 12x plus 12 plus 1. So all I have to do now is just condense this. So I'm running out of space, so I'm just going to erase this because we're going to collect our like terms. 12 plus 1 is just going to be 13. So we started in this form, which is vertex form, and now it looks like it's in this form. 3x squared, where a is 3 here. bx, negative 12x. c, and 13. So we're from this form to this form. We're going to do the same thing for this one now. So f at x is equal to negative 3, x plus 5 squared. Again, remember, you have to remember this. If you don't do this correctly at the beginning, you're doing the rest of it wrong. And it's easy marks, so please. So x plus 5, x plus 5. That's why we learned all the stuff in this order, so when we get to this point, we know not to make that mistake. Like all the chapters, I mean, because we learned this as review in chapters, chapter 1 and 2. Or we went over it again, sorry. So I'm going to do my foiling here. First, x times x is x squared. Outer ones, x times 5, 5x. Inner ones, plus 5 times x. And the last ones in the brackets, plus 25. Nothing on the outside this time. K is equal to 0. So I'm just going to keep simplifying. I know that 5x and 5x gives me 10x by collecting my like terms. And then I just multiply this out. Negative 3x squared. Negative 3 times 10x is negative 30x. Negative 3 times 25 is negative 75. So now we went from this form to this form by just showing this to the power of 2 as two different factors multiplying it out, and then foiling this, and then expanding by distributive property to get this answer. So let's get to more of a kind of a wordy problem here. We're going to do a bit more math here. This is example 3. It says write the equation of a quadratic function with a vertex of that passes through the point -1, 2. And then put it in vertex form and then into standard form. So what do we know? Well, we know the vertex. I'm going to try a little bit bigger. Hopefully I don't run out of room. The vertex we said is, in the question, underlined, -3, -6. And then passes through the point this. First in vertex form, then standard. Okay, so let's focus on vertex form. Remember, vertex form, x minus h squared plus k. The sloppy k, I'm very sorry. Try not to let that happen again. Okay, whatever. So the vertex, remember, this is our h value, this is our k value. So let's put that into our h and k value here. Y is going to be equal to a x minus -3 squared plus -6. Do you have to show all this? No, but I'm just doing this to show you how we're going to get to our why the signs are the way they are. So two negatives make a positive, like we said on the front page. Positive, negative give me a negative. So if you know this, you don't have to do this step. I just wanted to do this step to prove it to you. If you know that, oh, it's -3, in the brackets it'll be positive. -6 will be -6 at the end. You can just skip this step entirely if you want to. No, I'll keep it in there. I'm not going to cross it out. So we have this point now for our vertex form. But what do we not know? Well, we don't know x and y, but x and y change. They vary because they are independent variables. But the a value we don't know. I don't know what this is. So what else do they tell us in the question? It passes through the point this. So we have the point -1, 2. Well, what can we do with these? Well, these represent a point. We can say the first number is always an x value. The second number is a y value. I'm pretending that somebody's yelling it out in class. That's why I'm pausing like that. If you need to pause the video, don't be afraid to pause the video too. So I have an x and a y. What should I do with those? I have an x here and a y here. We're just going to substitute those in. So y is going to become 2. Like that, we have a -1 plus 3 squared minus 6. And what are we solving for? A. So I got to do some bedmath to simplify things, but I'm really isolating for a right now. So this is where it gets a bit algebra heavy. So again, if you need to pause the video, I'm gonna try and put some pauses when I'm doing the steps. Pause the video, copy it out, and then listen to me, or I trust you. Do what you got to do. So I'm gonna write it. First thing I'm gonna do is the brackets. So the brackets we simplify. -1 plus 3 on my calculator will give me 2 squared minus 6. That's probably the nicest writing I've done in a while. Alright, I'm running out of space. I'm gonna do one of these things. Just gonna rewrite it out again. Yeah, it doesn't look as nice. That's okay. So I have this. So now I'm gonna keep simplifying things. So I'm gonna do my exponents next. So I did brackets, exponents according to bedmass. Remember, these are beside each other like multiplication. So if you want, you can put this in brackets just to remind yourself, oh, this is multiplication. 2 to the power of 2 is 4. The reason why I wanted you to put that in brackets is because, remember, this is multiplying. Some people will just do 4 minus 6 here, but you can't do that because this is multiplication. So 8 times 4 is really just 4a minus 6. So you can see that if I subtracted these, I'm going to get a completely different answer. So now I get 4a minus 6. I want to get the a by itself. This goes to this side. 2 plus 6 is equal to 4a. I get 8 on this side. I want to isolate 4a. Divide both sides by the coefficient in front of the a. So 4 divided by 4 is just 1, or 1a, or just a. 8 divided by 4 is 2. So a is equal to 2. So now my vertex form equation is going to be y is equal to, well, a is now 2, x, we said the vertex is going to be minus 3, so it's going to be plus 3 in here, squared minus 6. That's just what we had over here, except now we know what a is. So we have a is equal to 2. So now this is our equation in vertex form. Vertex form. So now we have to put it into standard form. But how do we do? Oh, wait, well, that's what we just did up here, though. We just did this. So we're just going to get this, do what we did up here, and just do it over here. So I'm going to write y is equal to 2 x plus 3 squared minus 6. Alright, pause the video. Go and do it. Go and do it right now. I believe you can do it. If you don't do it, it's okay. Then we'll unpause the video. You'll see me do it. You'll catch the mistake. So pause the video and go do it. Okay, obviously I can't just wait for like 30 seconds. It's going to be a lot of time. So I'm just going to do it. Hopefully you pause the video and are just watching what I'm doing now and comparing to what I'm doing. Remember, x plus 3 squared is just it twice. Then we're going to use our kind of technique, little way to help us remember how to expand this out. First, outer, inner, last. Simplifying it further, x squared plus 6x plus 9 minus 6. Expand this out. Man, Mr. Lamb, why do you write so many steps? Why can't you just skip some steps? Again, I just want to make sure I'm not making a silly, careless mistake where I like add something wrong or forget a positive or a negative, or I multiply 2 times 6 and I add them by accident. Just showing the steps so I remember for myself. Alright, so I get to this. Like terms are these two. I get 2x squared plus 12x plus 12. So, was it a long question? Yeah, it's pretty good. It's a good question, I'd say. We have a vertex at the beginning. Put it into vertex form. We get this. They gave us a point. We get that point. We sub it in for x and y. And then we solve for a. We got a. Then I got the a value. X and y are just x and y because they can change. And then we have the vertex here. We had it in vertex form. We wanted to put it into standard form, so we just did what we did over here, but did it over here. So that meant writing this out twice, foiling, collecting like terms, distributive property, collecting like terms again, and we have it in standard form now. Alright, one last example, and then you can start at the homework, which is at the bottom there. So it says write the function f at x minus 3, x plus 9 in vertex form. So how do we do this? Well, there is something called completing the square where we could put this into standard form and then put it into vertex form. I'm just going to put that here. Completing the square will be later. You don't have to write this down. Some of you, I feel like I've already written it down, which is okay. You don't have to. I hope nobody's erasing it though, because that'd be a waste of time. So we'll learn about completing the square later. So how can I write this in vertex form? Well, if I know, let's say, the vertex, then I can put it in vertex form. So when I get my equation, looks like it's in factored form because of the two factors here, and because we just did a unit on this. I'm not trying to be mean or anything, just stating stuff. So I'm going to get my two factors. And how did we find the vertex before? Well, I get these into x-intercepts. Negative 3 comes over. 9 comes over. I have my two x-intercepts as 3, 0, negative 9, 0. So how did we find the vertex from this? Well, I can get the axis of symmetry, but if by getting my two different x values, my x-intercepts, adding them together, dividing it by 2. Negative 6 over 2. Then divide this, I get negative 3. So the axis of symmetry, we say, is negative 3, which in terms of the vertex is the h value, or the x value of the vertex. So now I need to figure out this k value of the vertex. So then I thought, well, how did I figure it out before when I had the axis of symmetry? How would I find the corresponding y value that goes with it? So what we would do is we would get this value and we would put it back into the equation to get the corresponding y value. In this case, the k value. So I'm going to put that back in here. I'm going to get f at negative 3. X becomes negative 3 wherever I see x. And then I'm going to just follow BIDMAS, brackets first, negative 6. Please, if you need to, use a calculator. I get negative 36 here. So my k value is going to be negative 36. So my vertex form equation so far is x plus 3 squared minus 36. Now I don't know this a value, but again, if I want to figure out the a value, I just need a point. So I'm going to pick a point. One of these 2 points should work. Let's pick this one because it's a smaller number. So I'm going to put 3, 0 here, x, and then y. So y is going to be 0, a is going to be this, x is going to be 3. I'm going to get 0 is equal to a 6 squared minus 36. I'm going to move this over here. 36 is equal to a times 36. Again, this is multiplied together. 36 is equal to 36a. Divide both by 36. A is equal to 1. So the a value is equal to 1. And this, I'm sorry if this was too quick, but all I did here was I picked a point, just like we did up here. Here we picked negative 1, 2, and I put that in there to solve for the a value. So I just did that again over here. To solve for the a value, I just picked a point. Before it was negative 1, 2 from the question, but for this example, well, we had x-intercepts. I just chose one of them. I could have chosen the 9, negative 9, 0. I would have gotten the same answer. So I just chose one of these, this one, to go here, x and then y, and I solved for a, and I got a is equal to 1. So my answer is just y is equal to x plus 3 squared minus 36, and you can put a 1 there if you want. That's pretty much it.